Hi everybody. So today I want to talk a little bit about depth of field. And I know depth of field has been discussed quite a bit on YouTube and blog posts and all these other places, but I wanted to talk about the myth about how focal length affects your depth of field. So first of all, I wanted to go over what depth of field is. So basically depth of field is what is acceptably in focus in your image. So a shallow depth of field means, just a little bit of your image will be in focus, so things in the foreground will be out of focus and things in the background will be out of focus as well. And technically whatever your plane of focus is on your camera or whatever you focus, when anything away from that, or front or behind that plane of focus, is technically out of focus. But our eyes can't perceive it, so that's why they call it what is acceptably sharp. So when our eyes and our camera can notice, okay, now it's starting to get not sharp, then that area is considered what is your depth of field, what is acceptably in focus. That's why people buy nice lenses. They spend a lot of money on nice lenses because how it can render your background out of focus, right? So as opposed to photoshopping, out of focus elements in your image, you can't really duplicate that in Photoshop, at least not well from what I've seen. Because what happens with depth of field is it's a gradual decrease of focus. So the further back away and further in the foreground, the focus slowly gets softer and softer until it's completely blurred. So for the longest time, I've always thought those were the three variables that affected my depth of field. It was your aperture, your distance to your subject, and your focal length. And then I started reading more about it and started researching a little bit about it, and then I found out that focal length does not really affect your depth of field, unlike how aperture and your distance to your subject does. It's science, it's math, so it's proven. But focal length just gives you the perception that your depth of field is shallower, when in reality it is not. Okay, the three variables that most people know about that affect depth of field are your aperture, your distance to your subject, and your focal length, right? So aperture is correct. The more open your aperture is, the more shallow your depth of field, and the more closed down your aperture is, the more depth of field, or more things in your frame will be in focus. And also your distance from your lens to your subject. The closer you are to your subject, the shallower your depth of field, and the further back, the larger your depth of field. Now, focal length, however, is not like this. It does not affect your depth of field in a large way. I mean, it does a little bit, but it's almost not noticeable. Because what the myth is that the longer your focal length, the shallower your depth of field, which is technically not true. Your depth of field is the same regardless if you use a wide-angle lens or a telephoto lens. It's how it behaves, and it gives you a perception that the depth of field is shallower, because what it's doing is it's magnifying the background. If you take a regular picture, I did some test shots on my own. If you take a regular picture at, let's say, 70 millimeters, and then you take another picture at 200 millimeters, you have the same shutter speed, the same f-stop. All you're doing is zooming in. If you crop the 70 millimeter image equal to the 200 millimeter image, you'll see that the depth of field is virtually identical. There is a slight difference in it, but it's not a big a variable as if when you change your aperture and your distance. That really changes your depth of field quite a bit. So what I did today was I did some of my own testing. Because you can see this more apparently with the longer super zooms, lenses they go from like 28 to 300 that just basically have a long focal length. So I took my my 70 to 200 lens, and I took the same picture at 70 millimeters and then again at 200 millimeters using the same shutter speed, the same aperture, and the same distance. Basically all I was doing is taking a picture and then zooming in, taking another picture. And I did this for several examples. And I'm going to go over these examples with you as well. And what I found is when you take the wider shot and you crop it to where it's equal basically to the same frame as the shot that was at 200 millimeters, the depth of field is almost indistinguishable. You can't tell if it's more shallow or not. There is a slight effect. It's not completely exactly the same because, like I mentioned, there is a slight effect, but it's hardly noticeable. Okay, here are some of the test shots I did today. So I had my camera on a tripod, I had my 70 to 200 lens on, had the same aperture and the same shutter speed. All I was doing was zooming in and out. And as you can see, it's really difficult to tell the difference between which one was shot at 70 millimeters and which one was shot at 200 millimeters. Here's another example of the same shot, only at a different angle. So here's a shot that was at 70 millimeters cropped in. So to get a little geeky with you guys, as you can see, the longer focal lengths may appear to have a shallower depth of field because they enlarge the background relative to the foreground because of the narrower angle of view when you zoom in. See, but this can make an out of focus background look even more out of focus because the blur has become enlarged. But this is just an effect due to the higher magnification, not the focal length. So in conclusion, I hope you guys try this at home. When I was learning photography, I learned that aperture, distance to subject, and focal length affect your depth of field. In reality, it's only aperture and your distance to subject. Your focal length is really negligible. It's very subtle. And there is another explanation to why it changes a little bit when you change your focal length, but I don't want to get too geeky on you. Just know that essentially it doesn't really affect your depth of field. It just gives you the perception of a shallower depth of field because of the relationship between the subject and the background is magnified. I hope you guys try this experiment at home. Do your own research as well, and I think you'll find that this is kind of eye-opening. At least for me, it was eye-opening.